In this video, we'll get some practice using the colon operator to access the data inside a matrix. So let's create a new cell here. This will be using the colon operator, that guy. Previously, we used the colon to create evenly defined arrays, one-dimensional arrays, like we said h equals 1 to 8. That gave me every integer from 1 to 8. I'm going to make mine 7 actually, just to make sure it stays on the screen. And I equals 0, 0.5 to 4. If you have 3 items using the colons, the middle is the interval, increment, I'll say. So counting by 0.5s, start at 0, keep going until you pass 4. That's what this means. We can also use the colon operator to extract data from a 2D array in matrix. It means you get the whole row or whole column. Let's look at our matrix G. So I'm using a matrix G here. It just happens to be a 9 by 3. As long as you have a matrix, then you can follow along. I've got G, so I'm going to say let's look at G. And remember how we could access using row, comma, column? So I could point to a particular item and say row 4, column 3. And I could see what that is. That one's 3, for example. But now I say, okay, I don't just want column 3. I want the entire 4th row. So what I'm going to do is change that 3 to a colon. This means give me the entire 4th row. The 4 is in the row spot, and the colon in the column spot means give me the entire thing. So I'm going to assign this a name. Let's call it J. I'm going to say, for J, I want to get a vector, a one-dimensional, it's going to end up being a one-dimensional vector, but what I want to put in it is from the matrix G, row 4, all columns. The colon operator is being used to mean all columns. So let's run that section, and now we can see what we've pulled out. J is a single one-dimensional array because it's the 4th row, but it has all the columns. And if we go over and look at matrix G, you can double-click on G from the workspace to open up this editor window. Row 4, column 3, that's what we're looking at. Or sorry, not column 3. All the columns. We're getting row 4, all the columns. All right, it works just as well if you put it in the other spot. Let's say all the rows, but give me the first column. Give me the entire first column. And if I run this section, now I'm looking at a column vector. So notice it's preserving the direction. If we wanted to turn this column vector K into a row vector, we would just transpose it using the apostrophe. All right, we can also get a range of vectors, or a range of columns. If we don't want all the rows, but we want some of them, we could say, give me, okay, not all the rows, but from row 2 to 5. So we're using the colon now in a slightly different way. It no longer means all, it means everything between these two numbers. So between 2 and 5 inclusive, maybe I still want the first row. First call, this is rows 2 through 5. Run this section. Now I've got a subset. I've got a little piece, 3013. That's this 30, -13, rows 2 through 5. So we can pull out a section. We can get rid of all or part. We can pull out any amount of pieces that we want. And you can do this in both. You could say, give me the matrix that's from G, rows 2 through 5, columns 1 through 2. And one other interesting thing you can do is say all the way to the end. If you don't know how big a matrix is, you can just say 2 to the end, and then maybe 3rd column. So end means last row. Or if we were using it in the column section, it would mean last column. So we can use literally the word end to say just everything from here on. And one last trick with the colon operator use of colon operator, turn a 2D array into a 1D array. So let's take a look at G again. You can double click, or if you still have it open in your editor window. Remember, this is a 9 by 3. We can see that over here. That means there's 27 entries. Well, we might like to look at them all in one giant column vector. So what I'm saying is I want to take this column and then put this column underneath it, and then this column underneath that. And that's what colon operator will do. This turns out to be pretty useful in MATLAB because MATLAB is so dependent on columns. So sometimes we want a column instead. Let's save this one as, well, let's save it back as A. Why not? I'll rewrite over A. I'm going to take G and just colon operate it. Notice it looks like we're using an index, but we're not exactly. We're indexing everything. There's only one input into this index. There is no comma. Instead, what we're saying is just feed it all to me, and I'm going to turn it into this operation. We'll save it as a single column. Let's run that section and take a look. So here's our, what did I call it, A? This is A, and it's now 27 entries long. And if we look at A, it's a 27 by 1. It has all the entries from G, and they're in the same order. So notice something interesting here is that note that A, any number you want, is the same as G of that number because they have the exact same entries. They're just rearranged. All right, now it's time for you to get some practice using colon operators. See you in the next video.